Hello my dear students, this is me Seema Banjare, your host, your mentor, your guide, and once again I welcome you to my channel. Take it seriously. I hope you all are healthy and happy. If not, then start taking care of your health, because you know there is an old phrase that says if wealth is gone, something is gone. If health is gone, some more things are gone, and if character is gone, everything is gone. But I'll say it differently and I'll prioritize the things differently. I'll say, if according to me actually, if character is gone, something is gone. If wealth is gone, some more things are gone. And if health is gone, everything is gone. Because health doesn't mean just physical well-being. It includes your mental health as well, right? And if that is gone, everything is out of your hands, okay? So take care of your health and happiness. And on this note, let's start the chapter, right? So this chapter is chapter number 6 of class 9 CBSE, and the name of the chapter is lines and angles. So this is going to be our first chapter on geometry. Okay, so for a while I was thinking how to go ahead with this chapter. So finally I came to a conclusion that the first video, that is this video, in this video I'll be including all the important terms and terminologies of the chapter. So terms, terminologies, theorems, properties, everything in this video. So this is one short video on all the properties and theorems. So next video on will be going exercise wise. So exercise 1, next video, exercise 2, next video. So this is how we'll be going ahead, because you know the questions of this chapter, you know the question, the statement of the question itself is so long, so lengthy, you know, so you need to, you know, to understand it, to invest time in understanding the question itself. And you know, one question can be solved by different properties, so it's better to know the properties first and then move ahead with the questions. Okay, so I thought this is going to be the best way of going ahead with. So let's start. We will start with the basic introduction of the chapter. Here we will discuss lines, line segment, collinear, non-collinear points, different types of angles, intersecting and non-intersecting lines. Then we will move on to discuss adjacent angles and linear pair of angles. Third, we will be discussing vertically opposite angles, then transversal and various angles related to transversal. And then lines parallel to the same line. And sixth, we will be discussing angles and property of a triangle. And finally, we will end up the chapter by discussing exterior angle property of a triangle. So for now, let's begin with basic introduction of the chapter. So my dear students, we'll be starting with some basics. Okay, so basics like point, line segment, collinear points, non-collinear points. So these terms will clear first. So if you think that you already know these things, you know, you can skip the initial portion and you can just move to the properties part, which I'll be discussing later in the video. Okay, but I need to tell all these things. Okay, so we'll start with point. Okay, so point is this. Point is basically it's really simple. This is a point. Okay, point is actually dimensionless entity. Dimensionless means no start, no length, no breadth, no width. Okay, so this is a point, and in mathematics we denote point by capital alphabets like A, point A. Now this is point B. You know, we denote points using capital alphabets, right? So now next comes two terms like line and line segment. Line segment. So there is a difference between, major difference between these two. Let's see what is that. So line is like this. Okay, means line, you don't know what is the starting of where this line has started. You don't know where it has started and where it will end. It is limitless. Okay, it can extend, you know, to infinity, both sides, both ways. Okay, so this arrow denotes that it can extend to infinity, right? So it has no starting point, no end point, no starting point, no end point. And if it doesn't have any starting or end point, it means you cannot measure its length. So you cannot measure its length. So the length is what? Length of a line is infinite, and you can say you cannot measure its length because you don't know where it has started and where it will end. Okay, but on the other hand, line segment is a small portion of a line. Okay, line segment has got a starting point and an end point. So you know where this line segment has started and where it will end. Okay, so if you know the starting and the end point, it means you can definitely measure its length. Okay, so it has got a definite length. So that's the basic difference between line and line segment, definite length. Okay, so this is the basic difference between these two. Clear? Okay, now let's talk about a ray. A ray has a starting point. Okay, you know where it is starting from, but you don't know where it will end. Okay, you know the starting point, but you don't know where it will end. So that is a ray, like, you know, a beam of light. Let's say the sun rays that are originating from the sun, right? You know they are originating from the sun, but you don't know where they, to what point they will extend. So that's why these are known as sun rays. Okay, so that's ray. The starting point is there, but there is no end point. Okay, so these are rays. Now, after this, let's come to collinear points. Can you see there? Like, is it visible? Collinear points. So collinear points are the points that lie in a line. Collinear points. Same linear line. Collinear points. The points that lie on the same line are collinear points. Okay, if these, I say that these points A, B, C, these 3 points are lying on this line L, then we'll say that A, B, C are collinear points. Same line, same line, linear line. Okay, so the points that lie on a line are known as collinear points. Okay, non-collinear points, just opposite of it. If the points are not lying on a line, then they are non-collinear points. Okay, non-collinear points, not lying on a line. So this much is clear. Okay, so now let's move on to discuss angles. Let's now talk about angles. Okay, so what are angles? When two rays originates from the same point, so this is a point. So when two rays, so this is ray 1 and this is ray 2. Okay, so when two rays originates from the same point, then they form an angle. So this is an angle, right? So they form an angle, and we always measure an angle anti-clockwise. Okay, so this is clockwise, the direction of a clock, hand of a clock. So this is clockwise and this is anti-clockwise. Okay, so we always measure angle in anti-clockwise direction, right? So let's name this point A, this is B, and this is C. So this angle, how we are going to name this angle at B? We will name it either angle ABC. You can either say it angle ABC, or you can name it CBA. This B, the vertex should come in center. Okay, you can either say it ABC or you can say it CBA, right? So this is angle, and this is how we are going to measure it. Like, what is the measure of this angle? This is how we are going to measure it, anti-clockwise direction. Okay, now so this is the vertex, this is vertex, this point from where these two rays are originating is known as the vertex of the angle, and these two rays are known as the arms of the angle. So what are the arms of this angle? AB and BC. So AB and BC are its two arms. Okay, clear? Now angle, so on the basis of their measure, okay, what is the measure of that angles? Angle are of different types, right? So let's see what all types of angles are there. Okay, now if an angle, let's say an angle, okay, if an angle is greater than 0 degree, right, and less than 90 degree, you know, 0 to 90 degree, less than 90 degree, if an angle is less than 90 degree, then it is an acute angle, okay. If it is 90 degree, exactly 90 degree, then that angle is a right angle. Alright, and if an angle is somewhere between 90 and 80, means greater than 90 degree and less than 180 degree, if it is somewhere between 90 degree and 180 degree, means if an angle is greater than, this is greater than 90 degree but less than 180 degree, or you can say if an angle is between 90 degree and 180 degree, then it is an obtuse angle. Okay, then it is an obtuse angle, right? Clear? Or if an angle is 180 degree, exactly 180 degree, means it will form a straight line, then it is known as straight angle. Straight angle. Clear? And if an angle is greater than 180 degree but less than 360 degree, if it is greater than 180 degree and less than 360 degree, then it is a reflex angle. Reflex angle. All right. Okay. So let's see how they look like, how these angles look like. Once again, 0 to 90 degree acute angle, 90 degree right angle, greater than 90 degree, less than 180 degree, it is an obtuse angle. Exactly 180 degree, it is a straight line, and more than, greater than 180 degree, less than 360 degree, it is a reflex angle. Okay, let's see how they look like. Now, so this is right angle. No. We'll start with acute angle, okay? So acute angle, as I said, acute angles are the angles which are greater than 0 degree but less than 90 degree. It means they lie somewhere between 0 and 90 degree. So how they will look like? So they will look like this, okay? Because they are less than 90 degree, okay? So this is 90 degree. When a line is exactly perpendicular to another line, then they form a 90 degree angle. So if anything is less than that, so if it is like this, it is 90 degree. If it is less than that, so it is less than 90 degree, okay? Acute angle will look somehow like this, right? Right angle. How does a right angle look? Right angle. A right angle looks like this, exactly perpendicular. Perpendicular means they form, this is 90 degree. And we always denote a right angle by this sign. Okay, so this is the 90 degree sign, right? So if I don't write 90 degree and I have just made this sign, it means that you have to understand that it is a right angle, because this sign is enough to say that it is a right angle, okay? So if 90 degree is not written, but somehow if the sign is there, then it means that this angle is 90 degree. You might find me a little bit sleepy from my eyes because it's exactly 2 p.m. right now, but you need to bear with me. I think that won't obstruct it, okay? So come back. So right angle. So this is how a right angle looks like. Now obtuse angle. Obtuse angles are greater than 90 degree but less than 180 degree. So how an obtuse angle will look like? It will look like this, okay? This, right? So obtuse angle can be anywhere between like 90 degree and 180 degree. So 120 degree is an obtuse angle, 170 degree is an obtuse angle, 130 degree is an obtuse angle, okay? Straight angle. Straight angle, when it is exactly 180 degree. So this is the point, okay? And this angle is 180 degree, straight line, okay? So this is a straight angle because it forms a straight, because straight angle means both the arms lie on the same line. When both the arms of the angle lie on the same line, then that angle formed, is 180 degree. And then comes reflex angle. It means definitely it is greater than 180 degree. Reflex angle. So how a reflex angle looks like this, okay? You're measuring from here, okay? 180 should be at this point, but it is greater than 180 degree, means this is reflex angle. So 270 degree, it is 270 degree is a reflex angle, 330 degree is a reflex angle. So greater than 180 degree but less than 360 degree, right? So what is how you can show a 360 degree angle? When it completes a circle, the whole circle. So how I can show a 360 degree angle? So if I start from here, like I started, like one arm is here and then second arm rotates completely and it overlaps the initial arm. So this angle, this hole, when it forms a circle, so this angle is 360-degree angle. Clear? So now let's talk about lines, okay? A pair of lines, right? So the lines can either be intersecting or non-intersecting. So they can either be intersecting lines or they can be non-intersecting, intersecting. And if they are not intersecting, then what they will be? Parallel lines. Okay. So let's talk about parallel lines first. So parallel lines are the lines which are parallel to each other, means they are at an equal distance. They are at at an equal distance from each other, like at every point. Okay, at every point, like the distance between these two lines is same everywhere. Like everywhere, let's say it is 3 centimeters. So this is 3 centimeters. At any point you measure, the distance between these two lines will be same. Okay. So they, the distance between two parallel lines is same at every point. Okay. And the parallel lines, we can also say that if two lines are parallel, okay, then they will not intersect each other, because the distance between these two lines is same everywhere. So there is no possibility that they will intersect each other. Intersect means they will cut each other. So this is pair of parallel lines. They will not intersect each other. That's why they are also known as non-intersecting lines or parallel lines. Okay. Now let's talk about intersecting lines. Clear? So either the lines are parallel, or if they are not parallel, okay, then they will be intersecting lines. They will intersect each other. Okay. They will either be parallel or they will be intersecting, right? So that's clear. Complementary and supplementary angles before that. So once we are done with complementary and supplementary angles, then we will move on to adjacent angles. Okay. So let's talk about complementary angles. So complementary angles are pair of angles whose sum is 90 degree. Okay. Complementary angles. When the sum of two angles, let's say two angles are x, one angle is x, one angle is y. When the sum of two angles is 90 degree. When the sum of two angles is 90 degree, then we say these two angles are complementary. Okay. Let's quote some example. 30 degree and 60 degree. These are complementary angles because they add up and they add up to make 90 degree, right? So these are complementary angles. If I ask you what is the complementary angle of, what is a complement of 45 degree? So the complement of 45 degree is obviously 45 degree because they both add up to make 90 degree. So the sum of these two, 45 is 90 degree. So the complement of 45 degree is 45 degree itself, right? If I ask you what is the complement of let's say 50 degree. So the complement of 50 degree is 40 degree, because 50 degree plus 40 degree is what? 90 degree, right? So complementary angles are what? The angles which on addition gives you 90 degree. A pair of angles which on addition gives 90 degree are known as complementary angles. Okay. On the other hand, supplementary angles are the angles. Complementary done. Coming to supplementary angles. Supplementary angles are the angles which on addition gives you 180 degree. So if the sum of two angles, is 180 degree, right? Let's say one angle is x, one angle is y. If the sum of these two angles is 180 degree, right? Then we will say that these two angles x and y are supplementary angles. Clear? Okay, so let's take some examples. 110 degree and 70 degree. These are supplementary angles because their sum is what? 180 degree, right? 90 degree, if I ask you what is, supplement of 90 degree. Supplement of 90 degree is 90 degree because 90 degree plus 90 degree is 180 degree. Let's quote some more examples. 120 degree. So 120 degree and 60 degree. So these are supplementary angles. Now let's discuss adjacent angles. Okay, so what are adjacent angles? Pay attention. Okay, adjacent angles. So for two angles to be adjacent angles, they need to fulfill three conditions. Okay, so what are these three conditions? First, they should have a common vertex. Common vertex. Okay, first thing, right? First thing, check. Second, they should have a common arm. Common arm. Right? So common arm, check. So one condition is still left, right? So common vertex, common arm, and the third and the most important condition, the common arm of these two angles should lie between the non-common arms. Common arm should lie between non-common arms. Okay. Now what does it mean? So for like two angles will be adjacent only if they fulfill these three conditions. Okay, now let's make it clear using, you know, a figure, because that's how it will be more clear to you. Now let's say this is a diagram, right? Here you can see there are three angles formed. Let's say this is A, this point is B, and this is C, and this is O. Okay, so the first angle is angle AOB, angle AOB, this angle, right? Second angle is this angle BOC, so this is the second angle, right? And there is one more angle being formed here, so this is this one, this angle. So this is what? This is angle AAOC. So three angles are being formed here. Let's see what all, like which pair of angle is an adjacent angle. Now let's talk about angle AOB, this angle, right? Let's rub this angle because I'm not talking about it, so it will confuse you. So I'm just talking about this angle and this angle. So angle AOB and angle BOC means I'm talking about this angle, angle 1, and angle 2, right? So this angle I'm talking about, angle AOB and angle BOC. So both these angles, AOB, vertex is O, and this angle is also having the same vertex O, right? So first condition is checked. They have a common vertex, right? Now they have a common arm. So this angle has two arms, AO and BO. This angle also has two arms, BO and OC. So they both have one common arm. Second condition, checked, right? And the third and the most important condition, the common arm should lie between these two non-common arms. And here this condition again gets fulfilled. So this is the common arm and this arm lies between these non-common arms, right? So that's why this condition is also, it gets fulfilled. So these two angles, angle AOB and angle ABOC, are adjacent angles. They are a pair of adjacent angles, right? Now, if I ask you, tell me whether angle AOB and angle AOC, now what I'm asking, angle AOB, okay, you understood what are adjacent angles, right? Now I'm just changing the angles, right, so that you don't get confused. So now I'm asking angle AOB means this angle and angle AOC means this angle, okay? So tell me whether these two angles are adjacent angles or not. Now let's check again for these three conditions. Yes, AOB and AOC both have the common vertex. Check. They have a common arm. So AOB, the common, this arm, AO and BO. Angle AOC, the arm is AO and OC. So they have a common arm, that is AO, right? So this is the common arm, and second condition is also checked. But the third condition, that the common arm should lie between these two non-common arms, this condition is not getting fulfilled. So that's why this pair of angles is not adjacent angle. It is not an adjacent angle, right? Because these are not adjacent angles, because in this case, the common arm is not lying between the non-common arms. Okay, so I think I made the point clear, right? So these were some basics about lines and angles. So far, we have discussed some important terminologies related to lines and angles. We've talked about different types of angles, right? Now, let's talk about the first property, or you can say theorem. So it is linear pair of angles. Linear pair of angles, okay? So what is a linear pair of angle, right? When two adjacent angles, when the sum of two adjacent angles is 180 degree, then they are said to form a linear pair, right? When the sum of two adjacent angles, now here angle AOB means this angle and this angle, angle BOC. These are two adjacent angles, angle BOA and angle BOC. So these are two adjacent angles. Linear pair of angle is such pair of angles, such if the sum of two adjacent angles is 180 degrees, sum of two adjacent angles, like in this case, if the sum of two adjacent angles is 180 degree, then they are said to form a linear pair, okay? So here BOA and BOC are forming a linear pair, and in that case these two non-common arms will form a line, okay? In this case, the non-common arm of the angles will form a line, and that's why it is known as linear pair of angles. Linear pair of angles, you get it? Or you can say it some other way also, that if a ray stands on a line, then the pair of adjacent angles so formed are supplementary or they add up to 180 degree, okay? Then such pair of angles is known as linear pair of angles. Clear? Okay, so basically what you get from here, that on a line if a ray is standing, then the sum of these two angles will be 180 degrees. It's as simple as that. Simple means if there is a line and a ray is standing on it, the sum of two angles on a line will definitely be 180 degree because they are forming a linear pair of angles. Clear? Okay. So now let's talk about vertically opposite angles. Okay? So if two lines intersect each other, let's say this is line L and this is line M. You know, you remember that what I told you, that we represent lines using small alphabets, small English alphabets, okay? So if two lines intersect each other, then they form a pair of vertically opposite angles. Two equal pairs of vertically opposite angles means if two lines are intersecting, then this angle will be equal to this angle and this angle will be equal to this angle because they are vertically opposite angles, okay? So this will be equal to this and this angle will be equal to this. If this is 30 degree, it will be 30 degree. If this is 160 degree, it will be 160 degree because they are forming a pair of vertically opposite angles, okay? If you want me to prove it, we can prove it here. You want to see it? Let's do it. Okay, now let's name these angles. This is angle 1, let's say this is 2 and this is 3, right? Okay, now just consider this line L. Okay, this is a straight line and angle 1 and angle 2 are standing on this line. It means you remember the previous theorem that we did, linear pair of angles. So you see angle 1 and angle 2, they are forming a linear pair, they are standing on a line. So it means they are forming a linear pair. So from here we get that angle 1 plus angle 2 is 180 degree because they are forming a linear pair of angles, okay? Now let's talk about this, right? This straight line. So this is a line and 2 and 3, angle 2 and 3 are forming again a linear pair. You can see 2 and 3 are forming a linear pair because they are again standing on a line. So angle 2 plus angle 3 is 180 degree because they are also forming a linear pair. Now 1 plus 2 is 180 degree from these two implies. So this plus this is 180 degree, this is also equal to 180 degree, which means that this side is equal to this side, means implies, this sign is implies, right? So angle 1 plus angle 2 is equal to angle 2 plus angle 3, right? So 2 is on both sides, so it will get cancelled out. So angle 1 is equal to angle 3, implies angle 1 is equal to angle 3, right? So 1 is equal to angle 3, and similarly we can prove that angle 2 is equal to angle 4. Clear? So this is the proof of, vertically opposite angles, that why vertically opposite angles are equal. So you need not to remember it. It's just for the sake of your knowledge. If there are, like knowledge hungry students, they want to know each and everything. So for those students, I gave this clarification. If you're not one of them, just leave it aside, okay? So just remember that if two lines intersect each other, then they form a pair, two pairs of vertically opposite angles. This equal to this and this will be equal to this. That's all, okay? So now let's talk about transversal line, transversal, okay? So be attentive while we do this, because it's, it's easy. But if you're doing it for the first time, if you are, studying it for the first time, then you might get a little bit confused. So be quite attentive here, okay? So what is a transversal? So transversal is a line that, intersects two or more than two parallel lines. Just listen the words. Transversal is a line that intersects two or more than two parallel lines. So here I'm just drawing two parallel lines. So transversal is a line that is, so these are two parallel lines. Let's say L and M are two parallel lines. If there is a line that cuts these two parallel lines, okay, these two parallel lines, okay, so this line is intersecting these two parallel lines, then this line is a transversal. So this line N is a transversal, okay? If any line that intersects two or more than two parallel lines, then it is a transversal. Now we will talk about different angles associated with the transversal line, okay? So here different sets of angles are formed. We'll talk about them now, okay? So here you see when two lines get intersected by a transversal. So you see 8 different angles are formed. So let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. Okay. Now here, so whatever, like these angles 3, 4, 6, 5. Can you see 3, 4, 6, 5? So these angles, the angles that are lying between these two lines, the angles that are inside these two lines, 3, 4, 6 and 5. These 4 angles are inside the lines, okay? So that's why these are known as interior angles. These are interior angles. If I say what are interior angles? Interior angles. So what are interior angles here? Angle 3, angle 4, angle 5 and angle 6. So these are interior angles. And the rest 1, 2, 7, 8. So these are exterior angles. So let's name them exterior angles. So what are exterior angles? Exterior angles are angle 1, angle 2, angle 7 and angle 8. So these are exterior angles. Clear? Okay. Now angle 1. Okay. So angle 1 is equal to angle 5. Okay. Angle 1. So on both sides, right, above the parallel lines and towards one side of transversal, 1 and 5. So these are corresponding angles. Corresponding angles. What are corresponding angles here? 1 and 5, 2 and 6. Corresponding angles will be equal. So angle 1 is equal to angle 5 because they are forming a pair of corresponding angles. 2 is equal to angle 6. Angle 2 is equal to angle 6. Corresponding angles. 7 is equal to angle 3. Angle 3 is equal to angle 7. So this angle is equal to this. 4 is equal to angle 8. Angle 4 will be equal to angle 8. Because why? Because they are corresponding angles, and all corresponding angles, corresponding pair of angles are equal. Okay, so corresponding angles clear, interior angles clear. Okay, so let's rub them off so that we can discuss further. Now let's talk about alternate interior angles. Alternate angles, alternate interior angles. Okay, now first interior word is there, means these angles, and alternate means one this side of transversal and other is that side of transversal. So 3 and 5 alternate interior angles, 4 and 6 alternate interior angles. So they form a pair of alternate interior angles. So angle 3 will be equal to angle 5 and angle 4 will be equal to angle 6. So they are forming a pair of alternate interior angles. On the other hand, if I say alternate exterior angle, so means it's clear, right? Exterior, angle 2 is equal to angle 8, angle 7 is equal to angle 1. So let's write alternate exterior angle. Okay, so what are alternate exterior angles? Angle 2 is equal to angle 8 and angle 1 is equal to angle 7. Clear? Okay, now so this much is clear. Corresponding angles, alternate interior angles, alternate exterior angles, and what are interior angles and exterior angles. So this much is clear. Okay, after this we'll come to property of co-interior angles. Now after this we'll talk about co-interior angles. Okay, co-interior angles. Okay, co-interior angles. So interior angles on the same side of transversal. So interior, talking about interior angles, but not all. We're talking about interior angles on the same side of transversal are supplementary. So what the property says? It says that interior angles on the same, this is really important, interior angles on the same side of transversal. So what are these angles? Angle 4 and angle 5. So this interior angles on the same side of transversal are supplementary. Supplementary angles I just told in the starting of this video. Angles which on, adding up gives you 180 degree. So 4 and 5 are supplementary angles. Interior angles on the same side of transversal, either this side or this side. Okay, interior angles on the same side of transversal are supplementary. So angle 4 plus angle 5 will be 180 degree. Okay, also angle 3 plus angle 6. Angle 3 plus angle 6 will also be 180 degree for the same reason. Interior angles on the same side of transversal are supplementary, and such pair of angles 4 and 5 are known as co-interior angles. 6 and 3 are known as co-interior angles. Interior angles on the same side of transversal are supplementary. Okay. So this is the first major theorem of the chapter, and this is lines parallel to the same line are parallel to each other. Okay, if you go with NCERT, then this is theorem 6.6 in NCERT, and here for us this is our first major theorem, and we'll show how, we'll show its proof. So lines parallel to the same line and are parallel to each other. So let's say what it says. It says that if there are two lines, like let's say this is L and this is M. So if two lines are parallel to one line, okay, to the same line, if L and M are parallel to the same line N, okay, then these two lines will be parallel to each other. What the statement says? It says that if L is parallel to N and M is parallel to N, so both of these lines are parallel to N, okay, parallel to N, then according to this theorem, these two lines L and M will also be parallel to each other. Okay, so what the statement of this theorem says? It says that these two lines L will be parallel to M. Okay, so we need to prove it. Let's prove it. Okay, so let's say this this is Q. Okay, so this is a transversal. So this is a transversal line. Now let's name these angles. Let's say this is 1, this is 2, this is 3. Okay, let's remove this angle. Okay, just for the sake of your convenience, so that you don't get confused. Now what it says L is parallel to N. It is already given to us. If L is parallel to N, okay, this is parallel to N, then angle 1 will be equal to angle 2. Why? Because these are forming a pair of corresponding angles, right? 1 will be equal to angle 2. Clear? Now, this line M is also parallel to N. L is parallel to N. It is given. Okay, means this angle 3 is equal to angle 1. This is equal to 1 because again, if this is parallel to this, then 1 and 3 are also forming a pair of corresponding angles. So that's how angle 1 is equal to angle 3. Now, it implies angle 1 is equal to angle 2, angle 1 is equal to angle 3. So, it implies that angle 2 will also be equal to angle 3. So, it implies that angle 2 will be equal to angle 3. Means this angle will be equal to this angle. And if this angle, these two angles are equal, it means these two angles are forming a pair of corresponding angles. And that's why L is parallel to M. Okay, so this is proved. You get it? Right? Okay. So now let's move to the next major theorem of the chapter. So this is theorem 2 and the statement, this is angle sum property of a triangle. Angle sum property of a triangle, and the statement of this triangle says the sum of angles of a triangle is 180 degree. Okay, so this I think you already know. Will prove, but what we are going to do new here, will prove this theorem. Okay, so this, according to this theorem, in a triangle, the sum of all its angles, the sum of all three of its angles is 180 degree. The sum of angles of a triangle, so a triangle has three angles, so the sum of all these three angles will be 180 degree. So this is what the theorem of this statement of this theorem says. Okay, so we'll prove it. Okay, so let's say this is triangle A, B and C, right? So this is triangle A, B and C, A, B and C, and this is angle 1, this is angle 2 and this is 3. Okay, so we need to prove that 1 plus 2 plus 3 is 180 degree, right? So what we'll do, in order to prove this, let's draw at A, let's draw a line parallel to BC. So what we are doing, we are just, okay, so this is a construction, so it will be with dotted lines. Okay, so at A we are drawing a line parallel to BC. So this line we have drawn parallel to BC. So this line is parallel to this line. Okay, so this is parallel to this. Now let's name this angle. This is 4 and this is 5. Now this is a line, right? So this line forms, so this is the line and all these angles rest on this line. It means, so sum of all these three angles will be 180 degrees. So linear pair property. So angle 3 plus angle 1 plus angle 4 will be equal to 180 degree. So linear pair. Okay, so these angles, sum of all these three angles will be 180 degree. Clear? Now here you see that, let's say this is equation number 1. Okay, now this is parallel to this and this is a transversal. Let's say this line is parallel to this line and this is a transversal. So that's why this angle 4 will be equal to 2. Why? Because they are forming a pair of alternate interior angles. So angle 4 will be equal to angle 2 because they are forming alternate interior angles, right? Similarly, this is parallel to this. This is the transversal. So I've named, so this is 3. So let's name it 5. Okay, so let's name it 5. Not 3, it will be 5 because we cannot name, this is 3, this is 3. They both cannot be 3. So this is 5, now this is 3. Now, so if this line is parallel to this line, right? So this angle will be equal to this angle, again for the same reason, alternate interior angles. So angle 5 will be equal to angle 3. Again, the same reason. Now, in this equation number 1, let's replace the values. In place of 4, we can replace 4 with 2, and in place of 5, we can, replace 5 with angle 3. Now let's do it. So 5 in place of 5, because 5 is equal to angle 3. So we can write angle 3 plus angle 1 plus angle 4. 4 is equal to angle 2. So in place of 4, we can write angle 2 is equal to 180 degree. And what it is? Angle 3 plus angle 1 plus angle 2 is 180 degree. So this is proved, right? the statement of the theorem is proved. The sum of all these three angles of a triangle is 180 degree. So we have proved angle sum property of a triangle, that all the three angles of a triangle sums up to 180 degree. Clear? Okay, now let's move to the last theorem of the day of this chapter. Okay, so this is the last theorem of this chapter, and please bear with my handwriting. I'll also paste the snippet of this theorem somewhere so that you can you can understand the theorem, right? But yeah, I'll speak so it will be clear. If a line of a triangle is produced, if a side of a triangle is produced, then the exterior angle so formed will be equal to the sum of two interior opposite angles. Okay, in a triangle, if one side is produced, then the exterior angle so formed will be equal to the sum of two interior opposite angles. Let's see it geometrically. What does the statement of this theorem means? So if in a triangle, let's say this is a triangle, okay, so this is the triangle ABC, okay. If you produce one side of this triangle, if one side of a triangle is produced, then the exterior angle thus formed, right? This is the exterior angle. So the exterior angle thus formed will be equal to the sum of two interior opposite angles. Means according to this theorem, if I say this is angle 1, then this angle 1 will be equal to 2 plus 3, because these are two interior opposite angles. Okay, so now let's prove it. How it is possible. Okay, now we have to prove that angle 1, what we need to prove? We need to prove that the statement of this theorem, angle 1 is equal to angle 2 plus 3. So this is what we have to prove, right? So let's try doing it. So let's name this angle 4. Okay, so now this is a line, right? This is a line. So 1 and 4 are forming what? Linear pair. Okay, so angle 1 plus angle 4 is equal to 180 degree. Why? Because they are forming a linear pair. Okay, because that's why their sum will be 180 degree. Okay, now so this ABC is a triangle. ABC is a triangle. So sum of all these three angles is supposed to be 180 degree, because according to angle sum property of a triangle, we just did it. Okay, so angle 4 plus angle 2 plus angle 3 will be equal to 180 degree, because angle sum property of a triangle. Don't write these short forms in exams because your teacher won't understand it. Okay, ASP, angle sum property. I don't know whether they will understand it or not, but I'll definitely not give marks for this, if you write this short form, right? Okay, so 4 plus angle 2 plus angle 3 is 180 degree. Now 1 plus 4 is 180 degree, and equation second says angle 4 plus angle 2 plus angle 3 is 180 degree. Now from these two equations, like this is equal to 180 degree, this is equal to 180 degree, so we can equate, means this is equal to this, because they both are equal to 180 degree, implies this equal to this, means angle 1 plus angle 4 will be equal to angle 4 plus angle 2 plus angle 3, right? Now 4 is common on both sides, so 4 will get cancelled out. Now we are just left with angle 1 is equal to, what we are left with? Angle 1 is equal to angle 2 plus angle 3, and hence the statement of the theorem is proved. What is proved? That the exterior angle will be equal to the sum of two interior opposite angles. Okay, so if in a triangle a line is so produced, a side of a triangle is so produced, then the exterior angle thus formed will be equal to the sum of two interior opposite angles, right? Okay, well, with this we have come to the end of this video, and I have tried my best to include each and every small terminology related to the topic and properties, theorems of this chapter in one short video. Okay, so we'll see you in the next video. Till then, take care and bye bye. And yes, before going, don't forget to like, share and subscribe to the channel. Bye.